Comparing and scaling. Unit test. Sign at the fair advertises ticket prices for the carnival. You have red tickets, blue tickets, and yellow tickets, and each ticket has a different cost. You can get 50 red tickets for $37.50, 20 blue tickets for $16, and 5 tickets for five yellows for $5. So it asks for the unit price for each ticket. So when we're talking about the unit price for each ticket, each meaning division, unit price, so that's dollars divided by tickets. And you'll remember, when you're making statements of comparison, it is critical to get the units right, because there's a difference between ticket per dollar and dollars per ticket. So we always have to keep a very good track of the units. Here, again, it's asking for price, dollars per tickets. So for the red tickets, we have cost, which is $37.50. Each is division, and we have 50 tickets. Now it's 50 tickets. So it's acceptable to go ahead and use a calculator for this. So we're going to pull up our calculator eventually. Tick tock, the game is a clock. All right, so we have $37.50 divided by 50. So we get a cost of 75 cents per ticket. Now, I don't know why this seems to come up so often, but it does. The dollar sign always goes before, and the cent sign always comes after. So for the blue tickets, we're going to have 16 divided by 20. Come on, there you go. Obviously, this is going to not cooperate. So we have $16 divided by 20 tickets. That's 80 cents. Per ticket. My goodness. We're finding out how to take an hour on something that should only take 5 minutes. Then for the yellow tickets, it's going to be $5 divided by $5 divided by 5 tickets, which obviously is $1 per ticket. So then how much would 40 red tickets cost? Well, if we know the cost of 75 cents per ticket, and we want to buy 40 tickets, you just multiply that together. Kills me, makes me want to lie. So that's going to be $30. And no cents. So scrolling down, how many blue tickets could you buy for $20? Now a blue ticket is 80 cents, right? And so if we're going to have $20, we want to know how many groups of 80 go into it, right? So we're going to go 20 divided by 80. Oh my gosh. 20 divided by 80 cents, I should say. Let's try that again. 20 divided by 80 cents. My goodness. 20 divided by 80 cents is 25 tickets. And that makes sense because we know that each ticket is less than $1. So if I have $20, I should have just over 20 tickets. And I know that dividing by a decimal is going to give me a larger answer. Next page. Come on. There we go. So I'm sorry that this is taking ridiculous amounts of time to turn a page. There's nothing that I like spending doing more in summer than watching somebody else's computer take bloody forever to do anything. Okay. So here we go. Kathy, the crazy clown, gives away 2,500 balloons, which really means she is crazy. Her rival clown, Lazy Linda, gives away, slacker, a meager 1,600 balloons. Write two different kinds of mathematical comparison statements about the number of balloons each clown gives away. Now, there are nearly an infinite number of different ways that you could set this up. I will give two. Obviously, the easiest way of doing this would be to make a difference. So I would say 2,500 minus 1,600 is equal to 900, right? So that means that Kathy, the crazy clown, gives away 900 more balloons than Lazy Linda. Obviously, there are multiple ways you could do this. So then another way we could look at it is we could just make a ratio. We could say that the ratio of, and remember ratio, fraction, same idea. The ratio of balloons, because we have to talk about what we're using here, that Kathy gives away compared to Lazy Linda is, and I'm just going to use the raw numbers here. Now this is order dependent, so if I said Kathy first, Kathy's balloon total has to go first, 2,500. And if Linda's goes second, Linda's corresponding total has to go there. Now, obviously, it would make a lot more sense to simplify this. So I could have said, instead of 2,500 and 1,600, I could have said 25 to 16. And of course, you could make a statement of balloons, or sorry, percent. You could use other different ratios. You could use part to whole ratios. I used a part to part ratio. Kelsey, moving on. Kelsey makes $156 in 2 weeks at a job at a carnival. We're really working this carnival theme. At that rate, how much will she make in a 52-week year? So, first thing I want to know is how many groups of 2 weeks are there in 52-week year? So I'd have to divide 52 by 2, and that's obviously going to give me 26 pay periods. Now, I would highly recommend that you pay attention to your units, because that's going to tell you if you have the answer. Are they asking for the number of pay periods? Well, no. They want to know how many dollars they'll earn in a whole year. So then that means I have to multiply that by how much I get paid for each pay period, which is 156. So if I'm using my calculator, which I did get rid of and the computer still thinks I have it, now it's really going to be confused when I tell, okay, there we go. So we have 26 weeks times $156 per pay period. That means we're making a whopping $4,056 per year. Not great, but not bad for a part-time job. I'll move it up here. If she works 12 hours per week, how much does she make per hour? Now remember, this is in a 2-week pay period. So that means she worked a total of 24 hours for that 2 weeks, right? So we're going to divide what she made in 2 weeks by how many hours she worked. Because we want dollars per hour. Per meaning divide. And so she works per week, so she makes how much she makes, so that's dollars. Per means divide, hours. So I'm dividing dollars by hours. So 156 divided by 24. So she makes $6.50. I wish our babysitters only made $6.50. I'm sure you disagree with that vehemently. Kelsey is saving to buy a used car that will cost $2,200. How many weeks will she have to work to save enough money to buy the car? So this is kind of tricky. This is how I would go about it. So she gets paid every 2 weeks, right? And so I would take that $2,200 and I would divide it by 156. And so this is going to give me how many pay periods she needs. So if I go 2,200, up you go. There you go. Hello. Okay. Divided by 156. So that is a little over 14. Pay periods, right? All right, pay periods. So how many weeks is 14 pay periods? Well, there are 2 weeks in each pay period, so I have to multiply it by 2. So that is 28 pay periods. Now here's the thing, or 28 weeks. But remember, she was just short after 14 pay periods, or 28 weeks. So she would have to work a minimum of that next week to earn the amount that she needs. So that's 29 weeks. Now obviously she would have to wait a further 30th week to get her pay, because it doesn't come out on the 29th week. All right, there are 2 doors in the fun house. Woohoo, fun. The doors are similar rectangles. The tall door is 9 feet by 5 feet. And so I'm going to draw the doors. The short door is 4 feet. How wide? So I need to know what number multiplied by 9 equals 4. This is just scale factor stuff, remember? And we said the scale factor is the image, this is the image, over the original. So 4 over 9, which is equal to 4.4 repeating. So again, this says feet. So really, I want to know, because I don't say 0.4 feet, right? So we know it's 4 feet. But what is 0.4 inches? So I'm going to do 0.4 repeating times 12, because there are 12 inches in a foot. And so that's 4 feet, 5, and I'm going to round it down to just plain 5 inches. All right. Last one. Whoa. Tick tock. My computer's slow. Really slow. Maybe it's just Denver Public Schools. Oh my goodness. Here we go. Okay, got it. This is not the right unit test. Let's accentuate the negative. So now we'll wait a little bit longer. All right, is it possible that this is the only 2 pages? Let's double check. Did we skip this page? Oh my goodness, we did. All right. Sorry for going out of order. So I'm going to stop this video. I'm going to do the second page. Sorry to make life hard.